Hello. Still waiting for people to join. Um, just wanted to let you know. Okay, I'm just gonna go quiet for a bit. I'll uh I'll come back when we're live.
Broker to link it all up to Binalize without having to recreate the incident. So that's the other thing we're trying to solve.
I'm in a meeting.
All you gotta do
They're
is put it up
torturing
if
me.
you want.
I'm so sick.
Again, I don't.
Hello. Here's the deal. We are live.
Oh my God. Hey, everybody.
I pressed the button on accident.
Oh, I'm not ready to go live. I'm very sick, and still in a meeting. So,
Okay. We can cut this off of the YouTube video. You can cut the beginning and the end off. But people watching now can see us.
Great. Happy to be here.
Yeah. We'll do a real announcement
Great.
um when we're all ready. I think Ray is still planning to be here. Yeah, people watching live, y'all get to see behind the curtain a little bit. I accidentally pressed the button.
Yeah, it's behind the curtain where we're just chill, normal people vibing.
Yeah, that's right. Normal in quotes.
Yeah,
Is that a pasta shapes poster behind
it
you?
is. It's a lot of pasta and a lot of fruit. And yeah, these are all fruits and vegetables.
In case you need a reference when you're like cooking, you're like, what does lettuce look like again? Which
I know.
one's
I
the
feel like
lettuce?
I've looked closely at these pastas, and most of them I've never heard of, even though they
Uh-huh.
all look like things I've heard of. And so
Hmm.
it makes me a little skeptical of the like quality of the information.
You know what bugs me? When you go to a restaurant and they have some weird shape of pasta, but they just
Mhm.
name it like you know what it is.
Yeah. Like like
And
like orecchiette.
yeah, and
that's
or
the
like,
normal shape.
but like some weird one where it's like, it's not weird. Probably in Italy it's well known, but you can't get it at the supermarket, so like you probably aren't familiar with the word. And then you have to ask what is it? Is it
Mhm.
pasta? Like
Yeah.
why?
Oh,
And
I see. Yeah, where it's like maybe this is a mushroom, and like it's just like the
yeah.
presentation of like some kind of like word that you don't recognize in cream sauce, and you're like,
That's right.
did this grow or was it like was it
I
built?
don't know what it is.
Yeah.
Yeah.
Uh and I don't know. I don't know why that bugs me, but because they could just say like pasta. I'm not gonna like not order it because the shape is wrong.
Oh shit. I had
Hey.
headphones that I've been using
Hey Ray.
headphones. The audio has been getting much better because I've been using headphones.
All right, Ray, just to let you know, I accidentally pressed the button, so we're streaming already. I can cut this out
That's
from the
fine. No
YouTube,
worries. Yeah.
but we're I just want you to know before you reveal all of our secrets.
My daughter picked up my headphones and walked around with them, and I haven't seen them since.
Maybe she swallowed them.
She wouldn't do that. She's too small.
Oh, I'm not using headphones at all. Maybe I should. That might be better for recording quality, but I knew that it was going to be a Zoom call, so I was like, Zoom has pretty good noise cancellation.
It's up to you. You sound okay.
Yeah, it
Cool.
sounds good. Yeah.
Okay, I'm not gonna worry about it then. I'm so sick. I'm actually taking a sick day off work. Uh, but I got pulled into a meeting anyway. Uh, so uh
All right, shall we start? Anyone
Anyway,
let me yeah, all right. I'm sorry you're sick, Mia. I hope you feel better.
thank you. Thank you.
Um, all right. Hello and welcome to Apropos, the show about closure where we talk about closure. And now we're doing special guests because that's what people want. And we do have a very special guest today. But before I introduce him, we're going through our panel. We have Mia,
Hi.
Ray,
Hello.
I'm Eric. Hello, everyone. And our special guest today is Alex.
hey everybody.
We're
Two
actually
Alexes in a row.
only doing guests named Alex now.
That's
So
right.
if your
It's very
name is
specialized, very
Alex,
niche.
then yeah, okay, for guesting. Otherwise, we will not be seeing you.
This Alex happens to be an Engelberg.
Yeah.
And Alex, before we get into the questions, could you tell us a bit about yourself for
Yeah.
the audience?
My name's Alex. I This podcast is genuinely the first time I've thought about closure in a few years. Uh,
Oh,
Oh,
because
geez. Ooh, good. Okay.
because that's actually not true, and I'll explain later that I've actually been using Clojure a little bit at work. So that was a lie, but it's the first time anyone has actually asked me to talk about Clojure, which makes me feel good.
right, right, right.
Um, uh, but I am a software engineer, and I used to do Clojure when I was a child, and some people think that that's interesting about me. Uh, and uh, and
Second
I
generation, right? Your dad did
Yeah,
closure.
yeah.
There you go.
So
You might be the first second generation closure programmer.
Uh, that's that's really funny. That could be potentially true. Um, so and I've used Clojure at a handful of jobs over the years, and I used it professionally at three different companies, and right now I work as an engineer at Launch Darkly, which is not a Clojure shop, sadly, but I'm still having a good time, and I think Launch Darkly's cool. And so scandalous, I know, but now I'm a Go programmer.
Oh,
So
scandalous.
I know. Uh, and I've given a couple closure talks over the years that you're welcome to go find. Uh, and I still kind of remember them probably. Uh, and I think closure is really cool and great. And on the side, I am a musician and I really like making music and being funny and making comedy and stuff. And so you can find stuff that I've done also on the internet.
You are funny. You
Oh,
had
thanks, man.
very cool, funny videos. I always enjoy them.
I find myself saying a lot. It's just data. It's
It's
data.
just
It's
data.
data.
I haven't talked to
that,
Derek in a while. I hope he's doing well. I want to talk to him again because that was a fun thing that we did together.
yeah, I
Y-
feel like that became a meme and people don't even know where it came from anymore.
Yeah. I kind of feel like it was a meme before we did the talk that made fun of it because I feel like that's kind of why we made fun of it is because people
Right.
were saying it a lot.
You just
Um,
maybe caricatured it a bit.
yeah. Yeah.
Right.
Um,
So there he's talking about this talk that he and Derek gave at the Conj, right? It was the Conj.
yeah, it was
Um
like the Durham Clojure Conj in like 2018 or something.
It was like 300 years ago.
Yeah.
yeah.
It's pre-pandemic, so no one
Yeah,
knows
definitely
how long ago
300
it
COVID years, yeah.
Yeah, it's a talk that Derek and I gave called
Um
uh, oh, sorry. I was gonna jump in with more context if
yeah,
you
go
want.
ahead. Go for it. Go for it.
Yeah, it's this talk that we made called Every Closure Talk Ever, and the Alex and Stu and everyone was kind enough to put us at the end of the conference, so we got to basically make fun of everything that had just happened and talk about and basically sort of we did a sort of caricature parody talk kind of modeled after the classic like closure success story where people kind of like are attracted to the language for all the wrong reasons and then lean into all the weird quirks of it and don't totally understand it. So we were kind of just poking fun at some of the fun quirks of closure while also being a love letter to the community. And then we ended it with with sort of a trailer for the language that was very sort of like macho and over the top.
I feel like a like if we were like more professionally YouTube people at this point, we would like have that and like splice it in to
Oh,
this.
like roll the clip of the of
Yeah, like
Yeah,
let's roll the clip. But I don't know how to do that.
you're right. That would be cool, especially over Zoom. That might be hard, but no, I really found that talk like um deeply painful. Um I felt called out a couple times because of talks I'd given in the past. But that's what comedy is sometimes.
Yeah.
You're the butt.
Yeah, it's yeah, art imitates life and as such can be painful to experience.
Yeah, yeah,
Every
yeah.
every I was gonna go very dark. And I won't. Um
Right. Okay. Thank you for that intro. So you're doing Go now, you said.
Yes, yeah.
Okay.
Does that mean officially that you've gone?
Yeah, are you not part of the community?
I've
Can we just
gone
end the show
I
right
thought
now?
you
Well,
just said that you
it's the past participle of to go. I
I
don't know.
thought that you said that you bullied your company into letting you use closure.
kind of. It's less of a bullying thing and more that I have found small use cases for just using it myself and to expedite parts of my job. Basically, everything we do, I work on the back end. We use Go, and so we have no closure in production, and I don't think that's something I can really change, and that's fine. But one thing that is true though is LaunchDarkly has a lot of um, part of the thing with LaunchDarkly is that we do feature flags, and part of that is we have these SDKs that you can put in your code that integrate with any language that you are on, and that let you interface with LaunchDarkly and evaluate the feature flag values in your services. We have some really interesting, sophisticated SDKs that do a lot of like caching and streaming and stuff to get the values quickly. Um, but there's an SDK for pretty much every major language, including Java. And there are a lot of scenarios at my job where I need to kind of test a feature that involves, pretending to be an application that is interfacing with our backend and sort of uh, setting up sort of a toy example of something that might evaluate a bunch of feature flags. Like I was working on our experimentation offering for a while that sort of does like A/B tests using that feature flag infrastructure. So I was like, I need a test service that can evaluate a flag and see if the experimentation feature is doing what it says. And so, I realized that I could use the Java SDK from Clojure and just kind of do all this stuff in the REPL using
Mm.
a couple functions I wrote. And of course, because Clojure is a really nice expressive language, I was able to bang it out in like one file with a few functions. And
Right,
it's
right.
been pretty nice to just like and everyone like it's funny because everyone else is confused when I'm like, okay, let me pop up in my test service to like try something, and they're like, what is this syntax? What are you doing? Uh, uh, and but it's just a nice thing, and it's been nice to kind of refresh the closure part of my brain every like few months because I'll like have to go back into this one file that I maintain on my machine.
So any job can be a closure job.
Any job can be, yeah.
It
Just
really
find some
can.
back end like hidden thing you need to solve and
Yeah,
Yeah,
bust
if
out
you can
some
find Java,
babashka.
yeah, if you can find Java, you can find Clojure.
exactly. Yeah.
Yeah.
Are
I
Yeah.
you
find
ready? Are you ready for the questionnaire?
uh.
Yeah, let's do it.
All right. What's your editor of choice?
Um, do you want an answer for Clojure editor or any editor?
You know what?
Both.
Yeah, yeah. Let's
Well,
let's
I think
do
so.
it.
Back in the Clojure days, I feel like I was an Emacs guy, and I was really on the Doom Emacs train, which is like
Mm.
kind of a Vim sort of, it's sort of a pre-packaged Emacs with all the Vim stuff and all a bunch of other plugins, um,
Mhm.
and that was nice. And I uh, I haven't tried cursive in a while, but it looked promising. And right now, I've been using Goland for Go, and I think because of that, I've been kind of JetBrains pilled, and I like I like that world of. I think when I was working on Clojure every day, I don't know what things are like now, but I think a few years ago um, it felt like cursive was a good option for was probably the best option for like sort of an IDE for Clojure, but I never quite got it to work. But partly because I hadn't had the experience of working in an IDE for any other language, so I wasn't
Mm.
quite sure like what sort of workflow I was trying to model it after. So I was a little
Mhm.
lost when I opened up cursive.
Yep.
But now I've been using Golang, which is like full IDE, like lots of stuff baked in. And I'm definitely really enjoying all the features like the debugger and the like code references, like clicking on stuff and opening to like
Hmm.
jump to the definition and everything. So now I have an idea in my head of like how a really good IDE works. And so I think now if I went back, I would definitely try to make cursive work. And
Hmm.
I would probably
Interesting.
figure it out eventually. Because now I get it.
So Ray, you use
Yeah,
cursive, right?
I use cursive, and I think you're right. But I came from like JetBrains, IntelliJ for Java, so I kind of knew the infrastructure. I knew the kind of things he wanted to do, and yeah, it's just, yeah, it's so easy, it's so nice, you know. But obviously, the thing you want to do with Clojure is run a REPL and evaluate forms, and that's super easy with cursive, you know. So
Yeah.
yeah.
I think a
Yeah.
lot of what I was doing, I would really try to um I pretty much avoided ever using the REPL that was baked into the editor. I would pretty much just line REPL at the terminal and then try to make it
Right,
so
right.
that I had like a really good like user.clj that I could do like tools.REPL stuff in. Um
Mm.
uh
And then how would
so
you reload code when it
I would
changed?
use the I would use like Stuart Sierra's reset
Oh, with
basically.
like a watch on the files
No, I
changing or
didn't do
something?
file watch. I would just go in and reset whenever I wanted to reset.
I see.
Yeah, you're making
And
life hard for yourself there.
Yeah.
Very, very chaotic. Yeah.
Yeah.
yeah, it's like it was a little annoying to like. I think it forced me to structure things well,
Mm.
because it meant that I had to have everything be sort of reloadable, in, and it meant that the namespaces need to kind of be structured well too. So I think overall, I thought that workflow was kind of a win, in that sense. But then if I it but if I was like opening some other Clojure code base that hadn't necessarily set all that up yet, then I would be a little
Mm.
lost, and I would be like, uh, I might want some editor plugin that can do all the reloading out of the box.
Hmm.
And you said you use Doom. I'm currently experimenting with Doom. I'm about I guess a little over a month in with
Yeah.
Doom. It does do the with the LSP plugin, it does do the references
Oh,
now.
that's pretty cool.
Jump to
Yeah.
definition, list the references. It does feel a little bit hacked together. Um,
I feel like that's how you're supposed to feel when you use Emacs in any capacity.
yeah,
Like
but
like that's the entire value proposition of Emacs, is you can hack together your own setup.
sure, but it feels hacky in the sense of like you get Vim keys like 95% of the places, but then sometimes you don't,
But what's the
right?
difference?
And
I
it's
use Spacemax, which is the Vim key
Yeah.
bindings, but
yeah.
Doom is also Vim
Doom
key?
Yeah, it's
has
the
a
same.
Space Max feel, but
Oh,
it also does a ton of it has its own kind of package system
Yeah.
that
oh,
forces things to get pre-compiled so that everything loads as quickly as possible. So, you load Doom Emacs and it's like half a second, whereas you load like vanilla Emacs and it's like 20 seconds to start.
hmm.
Um, and even if you probably have more Doom packages because it comes with so much. So it's just little things like that where they've like optimized it. They've chosen packages for certain experience and like maybe modified them so that like they work together well. And then they've
I could be
done
convinced.
all the
I could be convinced to switch. I didn't know it. I never knew that it had Vim key bindings.
yeah, it has the Vim key bindings and it has the like
Uh,
leader key thing so that you have this like hierarchical menu of a bunch of stuff you can do. It's it definitely is like an investment because, I'm not gonna sit there and like rebind all the keys and stuff. But and you can't just like use a random Emacs package because you're gonna have to sit there and like add a leader key and do all, figure out what it's gonna be. But it works.
Yeah.
It works.
I do remember that. I think I kind of lucked out that most of the Emacs packages I was interested in had some kind of like evil integration also that
Okay.
just worked.
Yeah.
Um, but yeah, just like a random Emacs package isn't necessarily going to just work.
Right. Right. But I'm not big into configuring anyway. That's kind of why I went with Doom. Like, first of all, like I've been doing VI for a long time. I don't even call it Vim. I call it VI because
Yeah,
that's
anyone who has their dot files in a personal GitHub repo that's published somewhere is I fear them.
but
That's
I
like
know
where
the
I'm.
I
Yeah,
know the VI basics, but I know that about 15 years ago there started to be like this resurgence of VI in terms of Vim where they had all this idea of like things are composable. And I just never got it because I don't know, I want to learn the fewest keystrokes possible that gets the job done, and they seem to want to learn, well, I want a keystroke that inserts right where the cursor is, and I want one that inserts right after the next letter, right?
yeah.
The next character. And it's like I don't want two.
I
And
feel like
like
oh, I do.
if I didn't if I typed really slowly, I would get the appeal of needing a like the exact key for every little maneuver, maybe.
right, right.
But I feel like once I got H, J, K, and L like down in my brain, I'm like, I don't need anything else. This is I can just
Yeah.
move
And
and then do the thing.
that's like 90% of the argument for Vim, right? Is like you're not actually going up, up, up. You're going like
Like
Z,
3K.
yeah, exactly. Z, and you type the first three letters of the thing you want to jump to, and then puts a number next to each one, and you hit four because it's the
Yeah.
fourth one, and like
No, I'm
I
like I'm holding down K until my cursor gets there.
yes.
That's like an animal. Okay. But
Like
isn't
an
the whole
animal.
idea of like Vim now? You've got like Vim, you've got Z shell. Sorry, but I say Z shell, but Z shell. You,
Yeah.
you've got Vim, Z shell, and you've got all these packages, and it makes it sort of it makes it feel a bit like an IDE in the sense that you can scan files and you can like, scan the file system, integrate it with Git, blah blah blah.
Yeah.
So it's more than just because whenever I've used VI in the past, I always used it as a sort of operator, you know, kind of like it's the only editor on the machine, so
Right.
okay, fine, you just use the basic things, But as a kind of like sitting in there all day editor, it seems wild to me that you would do VI like that. But with
Mhm.
Vim, it seems plausible. I know co-workers that do it. Is everyone in like your job, Alex? Are they all on Goland, or has everyone kind of got different workflows?
I
You
think
know,
everyone
I'm
is
always
either
fascinated
on.
by those kind of when you come across people that are in different worlds.
Yeah, I think at least backend wise, everyone I've talked to is either mostly on Goland and sometimes on VS Code. Uh, and then I think I may have found a couple people using Vim, but I don't even know how you would really do that with Go. Like, I don't even know the setup. Uh, I'm very curious. I like, but that I guess is also a way you could do it.
If you use Vim with Go, tell us in the chat box. Tell
Yeah,
us
let us
kind
know.
of crazy things you are doing.
Because I think like with Clojure, I kind of understood why people would do Vim and Clojure because you could just do a REPL somewhere else.
Mm.
Like, but I
Mm.
think if you're really, I'm curious what the setup looks like to get that interactivity for a static language like that.
Isn't the idea of Go that you just write the code and then just run it, write it, run it, write it, run it, because it's like a super
Oh, because
fast
it's really fast
compiler?
compilation. That's a good point.
Yeah.
So that's probably the workflow. It's not exactly what I do, but that would make sense.
All right, so we kind of already got this one. But the next question is what's your closure story?
A
So,
Clojure story of like how I started like,
y-
interfacing with it.
yep.
I think uh let's see. So my closure story is um so I was infamously homeschooled and my dad infamously is a functional programmer that is really interested in the different academic pockets of computer science and uh and he I was definitely taking an interest to computer science stuff he was throwing at me. But because he was really interested in uh, sort of the sort of functional Lisp world and had a personal experience with that, and there's a lot of good like teaching oriented material in Scheme world, like with uh, like Little Schemer and Dr. Racket is like really good for like showing someone how to do like the basics like coding 101 can kind of can take an interesting shape if you use Dr. Racket because there's a lot of stuff in it. And so basically he kind of started me on Racket/Scheme. This was I think was like maybe it was I think chronologically this was either around when Clojure, the very first, alphas of Clojure may have been in circulation, but it wasn't really like a thing yet.
And how old were you?
I think I was like around like 8 or 10 when I was just playing around with some of the basic like writing some math in Racket and like
Uh-huh.
doing some basic like coding assignments. Um, and so when I did little projects in my when I would be working on my homeschool coding work and doing little projects, Racket kind of became my language of choice or necessity, I guess, because that's all I knew, and was using that for kind of all the assignments, which kind of worked for a lot of them because Racket has enough with like image processing and a couple of like turtle graphics libraries and stuff that I could do kind of the fun toy examples of how to do coding.
Hmm.
Um, uh, and also it even had like a couple like a GUI like library, so I could make little like actual applications that could run on something, which was kind of fun. Uh, and and then I think kind of in parallel to that, my dad was like, because he was interested in this stuff, he was like aware of Clojure and was like trying out like the earliest versions of Clojure and was using it for his projects. Um, and so at some point he showed it to me, and I started using Clojure for things. For all that, and then that became my language of choice. It was a pretty easy switch over, but it also kind of unlocked a lot of power in my like hobby projects because of being on the JVM and there's so much JVM stuff. So I was able to write a web server now,
Hmm.
and stuff like that. And so I would do like I competed in a couple of programming contests using Clojure, which was kind of funny. Um, Funny for them. It was normal for me. Uh, and and then so this was around I was maybe like 15 or 16 or so. And then I uh, got my first programming job was with a Clojure startup that I don't think they would have even thought to hire me if I weren't like already very familiar with the sort of ins and outs of Clojure at that point. But I think they were like, we need like they had made the bet on Clojure as a language, and then that here I was saying I am like know this language pretty well, and they were like, great. And so that was my entry point into like sort of like kind of pragmatic software development, I guess. And so I learned a lot through that first job and then like continued to work mostly in Clojure just because I was able to kind of because I really like working in Clojure and it happened to also be a great selling point for me as like a candidate for these companies that had made the bet on Clojure. So that's how I kind of just stuck with it, I think.
What I'm hearing is I need Dr. Racket to propagandize my kid.
Mm.
Yes,
That's
exactly.
what's gotta
Start them off
happen.
young.
Yeah.
Um,
I'm curious about that because I want to teach my kids to program, and
mhm,
I've kind of I started when my oldest was they're 12 now, but when they were 4, I started with like games that were like programming adjacent, that required the kind of reasoning that you would do with programming. But then I haven't done anything since. And one thing I was trying to do was Sonic Pi,
Oh,
just
yeah.
because they're getting into music and it would be something that they could play with. But oh, it's just this is probably too detailed, but it's like so hard to like give my older daughter a computer and then
Mhm,
my younger daughter like gets jealous and
mhm,
like now they fight over it and it's like nothing they don't learn anything, they don't get enough focus time on it.
yeah.
um so that's kind of the challenge. That's probably why I haven't done anything since they were 4 is 'cause
Yeah,
they're fighting over attention.
I feel like because I have a younger sister, and I feel like that dynamic definitely existed when there was
Mm-hmm.
like a shared computer of some kind.
Mm-hmm.
We
So
have a horrible
go
idea where the children can have any computer they can build. Uh,
ahead.
is this a solution or is this bad?
How far down the stack do they have to
Yeah,
be
right.
building?
Do you need to like wire wrap the computer?
They want to start there.
Could you do that? Like
Absolutely not. No. But that's the whole point of children, right? Is they surpass you.
Yeah,
Yeah,
right.
fair enough.
Just drop a box of resistors and capacitors. They'll figure it out.
Work
I
it
think I was
out.
Uh,
like, I got confused. I never really got the hang of game development. Like I was doing Scratch a lot. So like,
uh-huh.
Scratch is great. And I made a bunch of funny things in Scratch and a couple games. But I don't think I never, I like tried a couple of like real game development, like SDKs and languages and stuff. And I was immediately like, this was like when I was a kid. I was so intimidated by like having to sort of keep state and like pixels and memory in a sort of new way that was more real than like what Scratch was offering.
Hmm.
Um, and or like the whole sort of like I think the sort of reactivity of the app was all different because in Scratch you can just be like you can be reactive and say like when left arrow pressed move left and like do that.
Yeah.
You can just kind of express it intuitively, but then realizing like oh now in like this other, game development framework, I have to be like, I have to be on a loop that happens every frame and is checking when I am pressing the key and then moving. And now I'm thinking in terms of frames, and I've never done that before.
Right.
And that was like
Mhm.
totally, it kind of threw me off, and it made it hard for me to really like latch on to like hobby game development.
So here's another like interesting thing you brought up. Like you started with functional programming at a
Yes.
very early age for most, for the let's say the average person. And now you're doing Go, which is not functional.
Hmm.
It's probably clearly in procedural, right?
Hmm.
Um, how did you see that transition?
Yeah.
How did you like that?
I think that what it feels like to me is like, I think a lot of it is, I think that even in, it hasn't been as shocking of a transition as I sort of expected it would be.
Hmm.
Because partly because I think that like pragmatic closure isn't always like as functional as you would maybe want it to be. So I'd already been, trying to
Right.
when I was already working in a world where, I was working at these companies um with a lot of different closure developers that like I think when you have a like a medium, even a small sized closure shop, there's like a lot of different like styles of closure that
Understood.
happen. And so there's different like, oh, like you really have like someone who maybe already was super passionate about functional programming before they even joined was like I am gonna like really go out of my way to make this service like to make this meth endpoint code just like built in terms of these like elegant functional components that compose perfectly. And then there's like I'm going to uh I just want to be really pragmatic, and I want to make these I want to build this endpoint code in a way that is very like you know cost efficient as a developer to make this work and get to value quickly. And so you end up with a more procedural looking
Hmm.
closure function that maybe uses atoms in a weird way or something because it's like I needed some mutable state for this loop or something.
Right.
And that's great. And so we have multiple different options. And so I was already kind of used to kind of code switching, haha,
Yeah, sure.
um, uh, between these sort of worlds. And so I wasn't totally thrown off by kind of leaning more into the like, procedural thing of like, and I think, and then there's another thing where I noticed in Go, where in the Go world, people do still try to make their code elegant and composable. So like
Hmm.
that philosophy doesn't go away. Um,
And how does
just if
that
you're on Go.
work? Like I'm not very familiar with Go at all. How does the composition work in
I
Go?
think one thing like the composition is, I guess, non-existent because you can't really do that very well. But there's certain things that are there. Like there are like Go does have higher order functions and they work fine and they're
Hmm.
typed pretty fine, I think. And you can have middleware. So a lot of you can have
I
an
see.
endpoint with a stack of middleware on it. Like I already know how middleware works, and that feels like kind of functional in a certain way. Um, I think that there, I think I usually will try to, even though Go does not have like immutable data as a sort of first class thing, I think I kind of sense people tr like wanting to treat the data as sort of semi-immutable, like all
Hmm.
across function boundaries, and that helps because we all kind of have this shared general vibe that that's kind of a good thing to do. Where you're like, okay, if I'm going to like iterate over this array and like update filter over everything in the array and do something and then return a new array, I guess in Go it's a slice, but it's array-esque. Um, and you'll return a new sort of array of stuff, then that should probably be encapsulated in one function that is sort of invisible to the outside caller, and it should just be taking data and returning data. And also in at least the Go APIs I've worked in, there's a lot of structured data that's just a bunch of typed structs that are nested structs. And so there's just a lot of like, here's a bunch of data, I'm getting back a bunch of data kind of vibes. And so it already kind of feels familiar. It's just not dynamic and uh, one thing I miss is I mean, there's a bunch of things I miss from Clojure, just vibes wise and like things you can do. Um, I really liked the whole thing with like accretion in Clojure, where you can just kind of like, I think like I think that I liked the idea of sort of having a sort of a contract of here are the keys in this map that I kind of am expecting, but I to kind of have a more graceful migration between two components. You can just start passing new data that isn't documented yet, and then like you then gradually and the different endpoints kind of are eventually agree as you kind of accrete the contract. Does that make sense?
Yeah, yeah. I mean, so you kind of have this policy that's not enforced by anything in the compiler or anything, but
Mhm.
it's that I'm not gonna just destructure this map, get all the keys, and then make a new map with all those keys.
Yeah,
You should modify the original map because there might be
yeah,
keys that you didn't know about.
yeah,
And so pass along those extra keys because why not?
yeah.
And that's a thing that I don't see people using spec enough for. Like if they're
Mm,
gonna use spec and they're already like, oh, it takes one of these and it returns one of these, they should be writing a test that's like, actually, it's gonna if I pass it extra keys, they're actually gonna make it to the output. That's a great use of spec.
yeah.
Mm. I feel like context objects in other languages sort of serve that purpose as a sort of general
Yeah.
bag of values and keys and values.
Go contexts are very bag of values related. Like, and I've actually been that is the closest thing I've come to like feeling like I'm immutably conjing onto a map. Uh
Mm.
and it's really interesting. I actually really like it conceptually because it's basically a way it's a basically a in Go there's this thing called context.context. It's in the package called context and then there's a
Ah,
class called context and it's basically it's a struct that you can essentially um a context is just a map of keys to values, and then you can essentially do an immutable conj and say like with this value, and then you get back a new context that is essentially, but in structurally, it's actually structured more like a linked list. So you're kind of consing on the key value pair, and you get back a new context. And Go developers use that as a way to kind of append new information as a request gets deeper into a call chain.
yeah,
Uh,
yeah.
for
So like
specifically,
middleware might be adding stuff to the context
exactly,
or
yeah, that's a good use case. And so that is
so
a
the idea is they're taking the existing context and just adding to it. They're not,
yeah, and
yeah,
then they're passing that new context to the next,
right,
thing in the
right.
chain. And it also kind of ties pretty well into like observability too, because you can have like if you're tracing your call chain, then you can have a tracing library that kind of like stores kind of current span context on the like Go context so that you kind of remember where you are in the like honeycomb trace or whatever that you're like trying to instrument.
Hmm.
So there are two other things about Go that are different. Yeah. One is that Clojure borrowed from Go, which is the Go blocks. Come back to that.
Hmm.
We'll put a pin in
Yeah.
that and we'll call back to it later. That's the way it works.
It's
But then,
async.
then what we'll do, then the other thing that's sort of, yeah, exactly. Yeah, you get it. Some people will get it later, but it's so
Put a plus
yeah,
one in the chat if you got it.
okay. The other thing, it's like UDP, isn't it? But anyway,
Yeah.
the other thing is the error handling, which is quite annoying, I think, in Go. It's basically if.
Yeah.
That's the thing that's the thing I find like is tedious in Go.
Oh,
I don't
interesting.
know how you
I was
find
gonna
it.
I'm gonna challenge that and say that I really like that
Okay.
about Go.
All right, okay. Yeah, fair
Because
enough. Yeah.
or what one thing that I
You're error pilled.
I'm error pilled. I'm error pilled and early return maxing. Uh,
Okay.
I think specifically, I think what it's not that I enjoyed the boilerplate of the if error all the time, but one thing that I think is interesting is most languages, well, I get especially Java and Clojure, you have to do a lot of nested if else's to get or either I think that like the sort of weird reality of software engineering is that kind of all code is basically just a bunch of if else's and try catches. Uh,
Yeah.
and especially try catches because there's just like a lot of errors that you kind of are trying to handle in different ways because of like business requirements to not blow up. And so I think that like I enjoy that Go. I think that the early return model in Go kind of made it possible to not kind of creep to the right with all the nesting of different hand
Mm,
if of the different. So I think it kind of solves it for both if else and try catch, where if instead of doing an if else, you're sort of encouraged to do if this, then early return, otherwise keep going. Uh,
yeah. I
that
like that. I miss that in like I do some JavaScript too, and I do that all the time. Like at the top of the function, just do all these checks, and then
yeah,
you're in the clear. Once you all the checks are out of the way, they're guards, right? They just return early,
yeah.
and then you're in the clear. You can just do whatever you want because everything's been checked.
But that's totally possible in Clojure with spec and assertions. So,
But you can't do an early return.
Yeah, that's true.
You can have
Unless
a
you
thing
get
well,
that's
you can
if
actually,
you
because if you
use
do like S valid, if not S valid, bam, you return. You know?
yeah, yeah, yeah. I think
right,
it's less about it's more of the structure where it starts kind of creeping to the right because you have if and then now you're in this else block
right.
and you
You're
implement
doing
it more. So it kind of feels like you're deep in this
Sure,
nested
sure.
thing,
Yeah.
like logic. Also, if you use Mark Engelberg's special Better Con library,
Oh yeah, yeah.
shout out to that, you can avoid these kinds of situations.
better
Oh
Spin
boy,
dash
one
cons.
bits. Very
one
nice.
long infomercial.
Yeah.
Yeah, that was the longest plug for a library that I've ever seen.
Speaking of
I just
plugging a library, I used your was it constraint solver library?
Whoa, that's so
Yeah.
cool because I haven't maintained it for 6 years.
Well, it was probably more than 6 years ago when I used it, but
Oh,
it
okay.
was I was doing something. I was making a video editor.
Mm,
And I gave up, but I was making a video editor where I wanted to be able to say like um put these two together, these two video clips together, but have like a 1 second transition where you fade between them. And so it started to be really tedious to like keep track of like what's the position of this thing, like, the offset from the beginning of the video. And then if you move it over, okay, now we have to recalculate everything. And so it's just all constraint based. Everything just got a constraint. Like, what's the first,
yeah,
when do you
yeah.
start this video was a variable in the constraint system.
Hmm.
And it has to be with, 10 seconds after this one ends or, whatever. I had all these constraints in there. And, it worked. It was cool. Could
Yeah,
solve it all.
that's great. I'm glad it worked for you. Uh, yeah, that was a fun project. I was like, I think I was working on this course that was like, um, uh talking I was working on a computer science course called discrete optimization that was sort of talking about different um sort of heuristics and concepts for solving for solving like optimization problems, and one of the things they talked about was constraint programming as one of the tricks, and they just mentioned that there's a whole world of like different frameworks and engines for this. And then so I thought that was interesting, because I had always been curious about like writing code that like solves puzzles,
Mm.
and so that was
Mhm.
like seemed like an easy fit, and so uh, that kind of felt interesting to try to wrap a Java constraint programming library, which was called Choco, and then I wrote my Clojure wrapper called Loco. It's a very incomplete Clojure wrapper, and I wouldn't maybe I probably wouldn't use it in production necessarily, but I think it works.
But it made it nice and closury. and made it from
Yeah, yeah,
this
yeah.
thing where you're like constructing Java classes and
Yeah.
the gross parts of Java where you're like, there's no examples. I just have to read the Java docs and like look at the constructor signatures and try to figure out how to put these things together. And you made it really nice where you could use actual like closure forms like,
Mm.
you know, A equals B plus C,
Yeah,
in
yeah, yeah.
closure style, like prefix notation. But that was really cool.
Yeah. Yeah, that was fun. Like to try to figure that out. Like I think I was always wondered whether that sugar was like actually efficient because the way it would do that is it would be like it would see A equals B plus C, and then it would basically be like it would compile that into B plus C equals new temporary variable that then plus another thing should equal D or something like that. Like it would
Uh,
create a bunch of intermediate new variables that you didn't see that it was adding to the constraint engine.
uh-huh,
And I
uh-huh.
wondered if that much sugar was actually going to like shoot someone in the foot someday of like performance or something of like not kind of realizing the complexity of how complex was the problem they were feeding to the solver now. Uh,
Yeah,
um, but I never ran into that limitation on my own, but I was thinking about wondering about that.
that's cool.
So going back to core async then.
Call back.
So that's a joke. I'm
I've
kidding.
been parking here waiting
That's
for
a
you
good
to get
one.
back to that.
That paid off.
Uh,
All right.
Right. Okay. Next one, me, please.
Calling back, we have two more questions. So one of them is, when's the last time closure surprised and delighted you? Oh, surprised or delighted you?
I think like just like thinking back to recent like closure toys I was playing with, I thought Babashka was like really cool. Uh, I was like, I think just generally, I remember kind of recently being interested by this sort of new like Graal VM era of like
Mm.
tr
mm.
everyone trying to figure out can we get Clojure to work on Graal so that we don't have to deal with JVM startup time. That was fun. That was a fun era. Uh, and I think Babashka was a great outcome of that.
Mm.
Whereas we have no idea what percentage of closure programmers actually use Babashka apparently. So
That's what we learned last time. Yeah.
You don't know, like there's no data on it, or
The
you're
data is 90 something percent of the people who answered the question.
so it
So
seems what we can say for sure is people who use Babashka really like to talk about
they
that's
like
really
to answer that
it.
question.
Yes.
Yeah, it's cool. And I and
Ah,
I've been able to I mean kind of similar. I think Babashka is also great for like sneaking closure into work
mm,
um because you're always going to need to write little shell utilities, right?
yeah.
Mm.
And just sort of automate something that you need to do with the command line. And so like I like that that exists, and I can just also honestly, I've also used Babashka as purely a I want to do line REPL just to try some stuff, but I don't want to wait for line REPL to start up
Oh,
Yeah.
because BB enter is as takes 0 seconds to load up, and line REPL takes like 2 seconds to load up, so it's a big win.
Definitely.
I Babashka, I feel like it is such a savings over Bash
Hmm.
that it I'm writing stuff in the shell that I would not have done in Bash. Right? Like I'm making a script for a thing where I'm like, it's better, it's easier for me to just do it by hand
Hmm.
than to like figure out how to write this Bash script. But I am willing to figure out how to do it in Babashka because it comes with a certain set of libraries, so you have to like look up what library is being used and like what do I have available.
Hmm.
But if I want to hit a couple HTTP endpoints and then combine the results into something and print it out in a nice format, geez, good luck with doing that with Bash, right? Trying to hook up
Yeah, yeah.
curl and whatever else, sed and awk to get it to look right.
And
Um,
Also
Babashka gives
core
you a bunch of
processors as well.
I'm sorry I interrupted you. What were you going to say?
I was just going to say, you can make, there are such things as core processors in the shell, but yeah, who
Yeah.
knows how to use them, you know?
Yeah, right.
Sorry, Alex. Yeah.
I was just gonna say Babashka also comes with a bunch of like libraries that are sort of pre-compiled and you can just use, which I also makes it
Mm.
kind of better than Bash because you can just use a bunch of cool Clojure libraries that maybe don't have a Bash equivalent or a command equivalent. So that's cool.
I think it's like Perl for us, because, shell is kind of nice when you're just like REPLing it, as it were. But if you want to write something a bit more, then
Hmm.
even in the good
Logic.
old days with the shell, it was like, yeah, this is good. Let's use awk and sed, but they're kind of awkward tools, literally. I
Yeah.
mean, but Perl is a bit nicer, and I think it's like Babashka is serving that purpose now, isn't it? That for us
Hmm.
at least, rather than grabbing Perl, you just grab Babashka. Yeah.
Right.
Yeah.
And working with actual structured data when that's what you have is much better than printing it out on the command line with like
Mm,
white
mm,
space
mm.
separated and trying to reconstruct it
Yeah, I feel
with
like
something
I've done a
else.
little bit of Bash, especially when I worked at Circle CI because there was a lot of like spinning up stuff in an environment and like b doing shells, and so I was like in shells a lot. And Bash, I feel like the main thing I was always thinking to myself in Bash was like, what type is everything? Like, is it's all a string, but it's also not sometimes. Uh, and the sort of I really felt the like not just I guess you could say Bash is dynamically typed in a sort of twisted
It's
way.
definitely,
Stringly
Um,
definitely.
typed.
Yeah.
Yeah.
but in a sort of a way that does not isn't really nice to work with, whereas Clojure is like I at least kind of know that things getting passed around have a type to them, and I'm not going to
Mm,
get
mm,
bitten by this no this string happens to be a number and is going to get treated differently by this tool.
mm, mm. Can I just like take a little aside for a moment, Go versus sort of closure? And I noticed that because you mentioned Circle CI and now you're at Launch Darkly, it's like they're all kind of operational tools or ops tools or
Yeah,
DevOps or
yeah.
whatever you want to call them. And I notice, I suppose the whole world has noticed that the Go is used a lot in those environments. Um, but a bit like, I don't know why Python got scientists. Why did Go get ops people? Because it doesn't make any sense to me. But so do you have a kind of vibe for that or a feel for that?
Oh, that's a
Why
good question.
all these ops people are so keen on Go?
I kind of assumed it was a cultural Google thing, like
Right. Okay.
because you get a lot of I feel like a lot of the sort of DevOps thought leaders are Google folks, and so a lot of the tools like Kubernetes is I think Go question mark I forget. Maybe I'm probably wrong.
Docker certainly was. Yeah.
Um, but I don't know. I think some of that just kind of bled over. I'm not sure. I think um, maybe it's a sort of a because Go is so like pragmatism oriented in its conceit. I think then that maybe resonates with people who with sort of folks trying to build a platform that delivers value. So you're trying to kind of maximize you know like having a sort of a clean-ish code by default that delivers the value you're looking for, um, maybe resonates with folks. I'm not sure. Um, I assumed it was mostly kind of a sort of an incidental cultural foothold rather than like there's some sort of secret sauce in Go that people are looking
Right.
for.
Right. Yeah. Yeah. That
Um,
makes sense. Actually, that does make sense.
Is it, I mean, it does it have to do with I mean, to me, Go has two interesting things about it for this. One is the Unix like heritage, right? Like, he's got
mhm,
Rob Pike and it's got a very C-like
mm,
feel. But then also it's multi-threaded.
mm,
It's
yeah,
multi-threading and DevOps to me seem to go together where you're like trying to orchestrate like 12 test runners to go at the same time and you're always dealing with multiple things happening at once in the like distributed world.
yeah. It's just
Seemed like
I
that was
think
a good fit.
having a nice out of the box multi-threading is kind of like very appealing if you know you're going to build a backend web server of any kind, because knowing that you
Hmm.
just don't really have to think about that is kind of cool. And you're like, oh, there's a mutex that I can use. And
Yeah, it's funny though, for me, like it was meant to be a better C, but it hasn't filled that role actually because
yeah,
no one no one really uses it like that. It's not like
yeah.
Rust, which has turned out to be the better C, for
Right.
for many people. Go never really fitted that. It never really, the people in the Linux kernel or whatever, it never really
Right.
took off, in that sense. So it's
Mhm.
it's found a home in DevOps, and it's kind of like I just don't quite know why, but it's interesting
Yeah.
to get your field report, as it were. There's this
It's
vibes,
funny because it
always
seems like
vibes.
Rust is kind of stealing a lot of users from Go too, right? Like people who did jump over because
Yeah,
they're
yeah,
like, it's a
yeah,
better
yeah.
C, it doesn't have, memory problems because it has a garbage collector. Um, it wasn't a joke. Uh,
I'm just realizing you saying it like that made me realize just remember that was an original value prop, and then realizing how just remembering how much people are now trying to get away from garbage collection in
Yeah, right.
Rust
I
and
mean,
stuff.
because there's stuff where like, a lot of the JavaScript tools got rewritten from JavaScript into Go. And now they're being rewritten again in Rust
Yeah,
because
yeah.
it's even faster and probably, better type checking. And they just like that. Um, they like it to be fast and um,
It's less
correct,
pragmatic
I
though, I
guess.
think, because to me, like Go is more fungible. Like the compiler in Go is much more obvious. The
Yeah.
constructs in Go are
Yeah.
more obvious.
Hmm.
Whereas Rust, it's a mystery what to do with this goddamn borrower. It's you
Yeah.
can
Yeah.
get going in Go in a week or two. You're pretty confident, I think. Whereas with Rust, it takes a few months, I think, to become really
Right, but
like a
there's
native
a kind
Go.
of like crucible there, right? Like, oh, I passed, I figured it out. I got it to compile. Like I feel better as a person. Uh
It's not very pragmatic, though, is it? That's what I mean. Coming back
No,
to
right.
Alex's point.
Oh, that's kind of
That's
what I
right.
meant by pragmatic, I think, was just the fact that you can get going quickly and the fact that you can
Yeah,
build
yeah,
something that does the business need that you were trying to build.
Yeah. Yeah.
yeah, yeah,
That's how what I meant by that is just like
yeah,
business
yeah, yeah.
pragmatic. It's like like so far every time like what it was Circle CI made a switch to like now Go is the main language and not Clojure, and I feel like whenever a company I feel like makes that change, I feel like I hear the sort of cost of you of baking in a language or the sort of economy of using a certain programming language. It gets thrown a lot, especially when you switching to Go, because it's like there's a like a lower perceived cost of I guess finding people who know the language and are really comfortable in it, and like getting comfortable with the language is a lower cost. And yeah.
And is there also kind of a, Circle CI has kind of established itself. It doesn't have to do as much of the exploratory, what features are we trying to build here? Like, what do our users want?
Mhm.
Like a language like
Mm,
Clojure, where you've got such an intimate connection with the code,
yeah.
it's much easier for exploring.
Yeah,
Um,
once you've paid the cost of the understanding of how
yeah,
it all works, then you become very fast and very iterative.
right. And
I guess also the
you just want to like have an efficient language that like you can just throw bodies
Mm.
at to fix the bugs, right? Like
Yeah, and
it's
also I think the runtime overhead of Go is very small.
yeah.
If you're in ops, you want those agents and those things that you're running in the background to be like low memory, low CPU. I think that's another real
You don't
win
want an
for.
8 GB JVM for each little Docker container you got.
Yeah, yeah. Welcome to my world.
All right, I don't want to run out of time before we get to the good question.
Yeah, because I'm about to fall.
Where
I'm my allotted time for being awake is it's closing. I'm not yawning because I'm bored. I'm yawning because I can't breathe through my nose. and I've been awake for too long. But gonna need you gotta choose one. All right, you can define transducer or monad.
Oh, I'm definitely going to explain transducers because I feel like I actually understand it. Uh,
All right. No one's picked
um,
monad yet.
wait, really?
No,
Yeah.
didn't Ambrose try
No,
Monad?
Ambrose, remember Ambrose like whiteboarded transducers.
Oh.
No, what do you call him? He chose monoid
Oh,
is
Zach. Zach.
Zach chose monad. Just
Oh,
cheated with the member of the monoidal family, whatever they're
Yeah, the
called.
no,
family of
that doesn't
endofunctors.
count. That doesn't count.
Yeah,
I
endofunctors. Yeah.
think, I think, based on my recollection, a
Mhm.
transducer is like a middleware for reducers. Uh, um, it
Mm.
is, and in abstract, I know that it is trying to abstract the like what does it mean it's taking like if you have if you call like map increment on some list and you get back a new list where everything's incremented, you've done a like a transformation. You have a collection, which is the sequence, and the type of the collection is a sequence, and then you did a transformation on the stuff in the sequence. And so a transducer is trying to um, uh, give a sort of an abstraction for expressing what the transformation looks like of doing that, transforming the stuff without having to specify what kind of collection you're working with yet. Um, so saying like I know I can just say uh you know I know what it means um to kind of map a function over all the stuff or filter stuff out of stuff, or remove stuff from stuff. Like I can express how that works without having to commit to what shape the stuff is in. Like what bag of what collection type we have of the stuff, and then that can come in later. I don't know exactly why this is useful, but that is what they are.
I
Uh,
think they did it originally because they wanted to unify the way that like the collections worked and
mm,
with core
Core
async.
async channels,
Yeah.
yeah.
yeah,
So
that
they
makes
wanted to
sense.
have like they see that oh we have to do all of these specializations on these functions because now we're dealing with like these channels rather than these sequences, you
Right.
know.
So we have
So
to rewrite map and filter and
yeah.
everything just for channels. Yeah.
Yeah. It's also, and I don't know if performance was like the main goal here, but it does seem like if you express something as a transducer, if you do like if you do a reduce with a transducer, um, they made it really performant because it's just a bunch of nested function calls with no like cruft, I guess. Like there's no extra overhead that's happening. It's just a function that increments the value and then calls the next function. And so I would imagine it's very JIT friendly, hopefully, which is kind of cool. I don't know if that's like a
Hmm.
value prop of it or anything, but I just remembered noticing that.
It's
I
certainly
think that's
garbage collector friendly, right? It doesn't create all those intermediate consts.
mm.
Yeah. Also, I was bantering about transducers a little bit earlier with Mia and some other folks, and someone said like or maybe it was me or someone else was like a transducers are a scam to sell dynamic typing. Um, at least that's kind of how I sort of feel like it. Not I don't think transducers are a scam, but I do think it's funny how um it's funny how quick I've heard people say like can static types do this? Like when talking about transducers, and it's like, nope, I don't think so. Like, uh,
Not
you
all of it,
could,
yeah.
but the structured typing of all these different functions that take functions and spit out other functions is probably got to be pretty insane. It would have to be like many levels of generics, I think, to make that work. Uh,
Higher kind of types, etc. Yeah, that's right.
I'll bet Scala could do it somehow.
I bet there's someone who's come up with maybe like a boiled down, like, you know, this is what a transducer's type is. Like there's there's a guy Edward Komet. He's
Mm,
good at that. He's good at like saying like, okay, there's this research in the scheme world, all this propagator stuff. Like, here's how I'm seeing it in terms of types. And
mm,
it's like not exactly the same
mhm.
because it's, it was an untyped thing and it's kind of loosey goosey. You could do whatever you wanted with it. Um, except it had a little structure. And now he's like, no, this is the way I'm seeing it as a typed thing.
Yeah.
And I'm sure someone's done that with transducers. They don't get all the benefits that we have, the like stateful transducers and stuff like that. Or even like early returns might be hard.
Mm. I think I remember I think I used transducers. I think transducers came out like when I was working at Amperity, and I remember there was like some use case where I was doing like I had this batch processor that would like, you know, every day load a bunch of data from some pluggable data source and then transform it and then dump it into some file that you could then run processing on. So it was like many gigabytes of data on sort of this like one job, and I was like looking for ways to kind of optimize or express it a little bit better. And I think a transducer kind of was useful because I could say that like I was doing the transformation as transducers. That was kind of because the transformation was dynamic and sort of expressed by the customer in a config.
Mm.
And then the reduction was sort of private in that I was like, I just want to write to this file and like this is how the reduction works. And so it was kind of an interesting tool for that. The performance didn't really like be, being able to not involve lazy sequences at all had no
Yeah.
performance impact on the equation, but it was just like an interesting thing to think about how I was like kind of cutting the middleman of data.
Yeah. Interesting.
Okay, I'm going to bed.
All right, we should wrap up. Are there any questions that you want us to ask you? There's two left. Anything
Uh,
you'd like to plug? That's a good one.
Oh, check out Better Conned. No, I'm kidding. You actually should if you think it could be
What
fun.
about Instaparse?
Yeah, check out Instaparse. It's still there. People still like it. Uh, we maintain it kind of. Um, uh, I don't. My dad does all the work now.
Hmm.
But it's still there. It's still maintained. Uh, it's pretty fun. We built it even though neither my dad nor I have ever had a use case for a parser, but we built it anyway. Uh,
Fun.
so we're hoping that it's good and it ends up
Fun
being
is your
good.
use case.
uh, and check that out. If you live in Seattle and you like comedy, you should watch me perform sometime. I do musical improv and it's pretty fun. And I usually talk about things I do like on my Instagram. So just search Alex Engelberg on Instagram. Um, so that's
Nice.
those are things that I do that I like.
Okay, cool. And who would you like to see on Apropos?
Let's see. It sounds like you've already had Zach Tellman on here.
Yep.
Is that true? Okay, well, I was gonna say him. I feel like I haven't heard from Gary Fredericks in a while, but he seems really funny.
Gary Fredericks.
He made the I can't remember like the
The
serious library.
Gemini server. Yeah.
Oh, he made test.chuck, which is a bunch of
Hmm.
utilities for test check. Um, and he also
Oh
made the
yeah.
library 71, which is a joke library that is the number 71, but he's never publicly acknowledged that it's a joke. He would be fun.
Do
Um,
you have to like import the number?
Yeah, so it's a library called 71, and you import like a namespace called 71 spelled out in English, and then it has a variable called 71 spelled out in letters, and then it's the number 71.
Oh, okay.
incredible.
Yeah.
Why 71? Is there some joke I don't get there?
I
Some
think
meaning?
I don't think there's any meaning to it.
Okay.
Hard to find
But
enough
Oh.
without meaning, but I hope that
I bet it's something to do with lambda calculus, but
um yeah,
it's just it's way more than a fun number.
It's like what,
also
the
you should have my
20th
dad on.
prime or something?
Uh uh,
You're
uh
dead.
I feel like
yeah.
he'd probably be down, and he uses
Is
Clojure
he
more actively.
watching this? Does he watch Apropos? Is he gonna watch this Apropos?
I think he was gonna tune in now, but he just had a conflict. Um, But I think he would. He probably would.
All right.
Nice. Okay.
All right. Well, thank you so much, Alex. I'm
Cool.
gonna go to sleep. So
Take care, Mia.
He
Get
is
better.
going
everyone.
to sleep.
Take care.
All right, bye.
Bye, everybody.
Don't forget to like and subscribe. All right, bye.